Physics Standard Level Paper 1 for May 2017, Time Zone 1. What is the unit of electrical energy in fundamental SI units? So electrical energy, so I can just use work done equals to force times displacement, which is force is F equals ma, which is kg ms minus 2, and then displacement is m, so kg m squared s minus 2. C. Which of the following is a scalar quantity, not velocity? Momentum has mass times velocity. Acceleration also no. So kinetic energy. All energy is scalar. An object is released from rest in the gravitational field of the Earth. Air resistance is negligible. How far does the object move during the 4th second of its motion? So it's asking for only the 4th second. So from t equals to 3 and t equals to 4. How far it traveled. So we know the acceleration is 10 because it's just rounded here in paper 1, and then the initial is 0 because it's from rest, and then the final you don't need the final velocity. So t1 is like t3 is half times 10 times 3 squared, which is 45, and then t at 4 seconds is half times 10 times 4 squared, which is 80. So then subtract each other, it's 35 meters. The graph shows variation of speed v of an object with time t. Which graph shows how the distance s traveled by the object varies with t? Well, it's definitely not linear, and it doesn't go backwards because it's all positive velocity. And from here we can see there's like a very small velocity, right? So that means it'll be a small change in displacement. Whereas here has a very high velocity, so the distance will be very high. So you can see that in this one, but not in this one because it's reversed. So the answer is B. Two boxes in contact are pushed along a floor with a force F. The boxes move at a constant speed. Box X has a mass m and the box Y has a mass 2m. What is the resultant force acting on Y? Because it says resultant force and it's at a constant speed, you just automatically tell it's just 0. An elevator and its load have a total mass of 750 kilograms and accelerate vertically downwards at 2 meters per second squared. What is the tension in the elevator cable? Well, you can use the formula F equals to ma for the resultant force, which is about 750, and then you times it by 2 because the acceleration is 2, so that's like 500 newtons. So then this is our resultant force, right? And you have tension and you have the weight. So our acceleration is also going this way, right? So it'll be the weight minus the tension, because it's opposite direction, will equals to the resultant force of this. So the weight using gravity as acceleration, so we can just times by 10, so 7,500 minus tension equals to 1,500. And then just rearrange, then we get tension is equal to 7,500 minus 1,500, so that's 6,000, or 6 and in kilonewtons. The graph shows the variation of force acting on the object moving in a straight line with distance moved by the object. Which area represents the work done on the object during its motion from P to Q? Work done is force times distance, and since it's from P to Q, we'll just need to find the area of the graph from this point only. So it's just z plus y. car traveling at constant velocity covers a distance of 100 meters in 5 seconds. The thrust of the engine is 1.5 kilonewtons. What is the power of the car? So we can find the velocity is 100 divided by 5, which is about 20 meters per second. And if you check the formula booklet, power is equal to force times velocity, which is 20 times 1.5 kilonewtons, which is equal to 30 kilowatts. So D. An inelastic collision occurs between two bodies in the absence of external forces. What must be true about the total momentum of the two bodies and the total kinetic energy of the two bodies during this interaction? Well, momentum is always conserved regardless, so that's crossed out. And because it's inelastic, kinetic energy is not conserved within the two bodies itself. So it's just A. Only momentum is conserved. A liquid is initially at its freezing point. Energy is removed at a uniform rate from the liquid until it freezes completely. Which graph shows how the temperature T of the liquid varies with the energy Q removed from the liquid? Well, because it's at freezing point, there's latent heat going on, and that means that the temperature is just staying the same until it freezes. So it'll just be this. A thin-walled cylinder of weight W open at both ends rests on a flat surface. The cylinder has a height L, an average radius R, and a thickness x, where R is much greater than x. What is the pressure exerted by the cylinder walls on the flat surface? Well, pressure is force over area. So it's the weight divided well, by the out. So like the area of this whole thing, and then the area of the inside. So pi r squared, and then minus pi r minus x squared. So then we can expand this to weight over pi r squared minus pi r squared plus 2 pi r x minus pi x squared equals to w over 2 pi r, because these cancels, minus pi x squared. 2 pi r x minus pi x squared equals to w over 2 pi x r minus x. And because it says r is much greater than x, I guess it's basically saying that x is negligible here. So I can just, the answer will just be w over 2 pi rx, which is A. I find this question very dumb, but moving on. A fixed mass of an ideal gas in a closed container with a movable piston initially occupies a volume V. The position of the piston is changed, so that the mean kinetic energy of the particles in the gas is doubled, and the pressure remains constant. What is the new volume of the gas? So we have the formula PV equals to N RT, and because we know if the kinetic energy is doubled, then EK equals to 3 over 2 kBT, then it becomes times 2, so it's just 3 kBT. That means that the temperature is twice, because kb is a constant, so only temperature can change. So what changes in this one is N R 2T. And because N is constant, R is constant, P is a constant, and only T changes, that means that V has to also be 2V for the pressure to be constant. So the answer is C, 2V. a particle undergoes simple harmonic motion. The graph shows the variation of velocity v of the particle with time t. What is the variation with time of the acceleration a of the particle? Well, we can see at this part, the velocity has a positive gradient, so it's increasing. So that means the acceleration is also positive. So this this is correct, at least until this point too. And at this peak here, that's when acceleration is zero, just like this here. And yeah, at this point, it's decreasing, so acceleration is zero. So this one still fits the criteria. So the answer is A. What statement about X-rays and ultraviolet radiation is correct? Well, uh, just for reference, first is visible light, and then ultraviolet, then X-ray, and then gamma ray. And at this point, here has the highest frequency and lowest wavelength, and then yeah, just the frequency gets lower here, and higher wavelength here. So X-rays travel faster in a vacuum than ultraviolets? No, because they're both electromagnetic waves. They travel the same. X-rays have a higher frequency than ultraviolet. That's true according so far, so that's a potential. X-rays cannot be diffracted, unlike ultraviolet waves. Nope, because it's the light wave still should be fine. Microwaves lie between X-rays and ultraviolets in the electromagnetic spectrum. Nope, microwaves is all the way over on the other side. So the answer is B. Two pulses are traveling towards each other. What is a possible pulse shape when the pulses overlap? Well, it definitely can't be this unless it was this and this. And it can't be this because the shape is wrong. And this will only probably be possible if it was like this. So it can't be this either. So the only answer is this one. Unpolarized light of intensity I0 is incident on the first of two polarizing sheets. Initially, the planes of polarization of sheets are perpendicular. Which sheet must be rotated and by what angle so that light of intensity I/4 can emerge from the second sheet? So we have unpolarized light going through the first polarizer. So then I, and then after the unpolarized light is polarized, it becomes I/2 automatically, regardless of this orientation. And then afterwards, this is when you can start using the rule I equals to I cos squared theta. So we have half already here, right? And you want here to be I/4. So that means you'll want cos squared theta to equal to I/2 to get to, yeah. So that means cos theta equals to, I mean, not I/2, it's just half. Cos squared theta equals to half. So cos theta will equal to 1 over root 2. And then, yeah, so theta equals to cos minus 1 over root 2, which equals to, yeah, these ones. And it doesn't really matter which of these get polarized first. I mean, which one of these is rotated because it still gets polarized. So it can be either. So the answer is C. When a sound wave travels from a region of hot air to a region of cold air, it refracts as shown. What changes occur in the frequency and wavelength of the sound as it passes from the hot air to the cold air? Well, when it comes to refraction, frequency is unchanged. And because cold air is likely harder to pass through because, yeah, the molecules are more like closely packed and stuff, so it makes it harder. So probably have a higher refractive index. So a higher refractive index would mean that it would have a lower uh, wavelength because, yeah, it just slows down. A lower wavelength and a lower speed. So it decreases. So the answer is B. The graph shows the variation of current with potential difference for a filament lamp. What is the resistance of the filament when the potential difference across it is 6 volts? Well, resistance equals to voltage over current. So equals to 6, and then when it's at 6, it's about 9. So this is at milliamps, right? So it's 6 times 10 to the power of, no, down here, times 10 to the minus 3. So it becomes positive. So it becomes like 2 over 3 times 10 to the power of 3. So about 0.66666 times 10 to the power 3. So it's about 6.670 rounded. So C. An electron is accelerated through a potential difference of 2.5 MV. What is the change in kinetic energy of the electron? So you can use work done. So work equals to uh, voltage times charge. And you can use the formula booklet to find the value of Q and also what M is. So it's 2.5 times 10 to power 6 volts times 1.6 times 10 to the power minus 19. So 10 to the power 6 times 10 to the power minus 19, that's 10 to the power of minus 13. And 2.5 times 1.6 is similar to like 1/4 times 10 times 1.6. So that's just 4. So 4 times 10 to the minus 13. So if we want it at 0.4, then it'll be 0.4 times 10 to the minus 12, which is C, because it's, yeah, 0.4 P. Yeah, I don't know what it is. A cell is connected in series with a resistor and supplies a current of 4 amps for a time of 500 seconds. During this time, 1.5 kilojoules of energy is dissipated in the cell, and 2.5 kilojoules of energy is dissipated in the resistor. What is the EMF of the cell? So we have the energy in the cell and energy from the resistor. So power equals to work done over time, which is 1.5, at least for the cell, 1.5 kilojoules over 500. So like get rid of the kilos, so it becomes 1500 over 500. So like 15 over 5, which is 3 watts. And same for this one, 2.5 kilojoules over 500. That becomes like, yeah, 25 over 5, so 5 watts. And then since uh, power equals to voltage times current, and that voltage is conserved, then the EMF is going to be equal to uh, 3 watts over 4 amps plus 5 watts over 4 amps, which is 8 over 4, which is 2 volts. So the answer is D. An electron traveling at speed v perpendicular to a magnetic field of strength B experiences a force F. What is the force acting on alpha particle traveling at 2v parallel to a magnetic field of strength 2b? 0. Because there's only a force if the forces are if the magnetic field and the velocity are perpendicular. If they're parallel or like anti-parallel, there's just there's no force. A horizontal disk rotates uniformly at a constant angular velocity about a central axis normal to the plane of the disk. Point X is a distance 2L from the center of the disk. Point y is a distance L from the center of the disk. Point y has a linear speed of v and a centripetal acceleration a. What is the linear speed and centripetal acceleration of point x? Well, we use for the v equals to omega r, and if the length is twice, that means the velocity is also twice, so it's just 2v. So this and this. For the centripetal acceleration, um, a equals to v squared over 2l. So if v squared is 2, if the velocity is 2, then it'll be 4. So these cancels out to just 2a. So it's this one, v. An object of constant mass is tied to the end of a rope of length L and made to move in the horizontal circle. The speed of the object is increased until the rope breaks at speed v. The length of the rope is then changed. At what other combination of rope length and speed will the rope break? For this one, you can just trial and error each option to see if it works. So F equals to mv squared over r. If your rope length was 4 and your v was 2v, then it'll become 4v squared. So it becomes 1 cancels out. So the force stays the same. So this will be the same. If it were this, for example, it was just v over 2l, then the force would be half. So it wouldn't. And for this, yeah, it'll just get smaller and smaller. A nucleus of phosphorus decays to a nucleus of silicon with emission of particle X and a particle Y. What are X and Y? Well, if you can see, it's like the proton number is from 15 to 14. So that means that one of this has to be a positive 1 here. So it's a positron, not an electron. And then because this means it's decaying a positron, it'll produce a neutrino with it, not an antineutrino. So the answer is D. What is the definition of the unified atomic mass unit? It's 1/12 the mass of a neutral atom of carbon-12. That's pretty much it, yeah. In nuclear fission, a nucleus of element X absorbs a neutron N to give a nucleus of element Y and a nucleus of element Z. What is magnitude of the binding energy per nucleon of Y over the magnitude of binding energy per nucleon of X, and total binding energy of Y and Z over total binding energy of Z? Well, for energy for Y over X, we know that after decaying, the new product is always more stable. So it means it'll have a higher binding energy. So at least with this one, it'll be greater than 1. For here, the total binding energy of Y and Z and the total binding energy of X. Like I said before, the binding energy per nucleon is going to be higher for in these than this one. And because like basically mass is conserved majority, at least the nucleon numbers are. That means that the binding energy of these ones, which is the nucleon times the binding energy per nucleon, is also going to be greater than 1. So A. If you want a very good explanation, just copy and paste the question, and yeah, you'll find a good video from that Varun dude. What is the energy equivalent to the mass of one proton? Um, if you check the formula booklet, we'll see the mass of a proton is 938 mega electron volts and C minus 2. And then we know mega means times 10 to the power 6, and an electron volt has a charge of 1.6 times 10 to the power minus 19. And then you can ignore the C minus 2 because this is the mass of a proton, right? And energy is the mass times speed, so this cancels out. So it becomes 938 times 10 to the power 6 times 1.6 times 10 to the power minus 19. So D. The following are energy sources: a battery of rechargeable electric cells, crude oil, a pump storage, a hydroelectric system. Which of these are secondary energy sources? Crude oil is definitely not one because it's a fossil fuel. Uh, Rechargeable electric cells are because, yeah, it's electrical energy. And pump storage hydroelectric system. It's also a secondary source because it's a pumped storage. That means it's using energy to bring the water back upwards. So the answer is going to be 1 and 3. So B. Planet X and Planet Y both emit radiation as black bodies. Planet X has a surface temperature that is less than the surface temperature of Planet Y. What is the graph of variation of intensity I with wavelength lambda for the radiation emitted by Planet Y? The graph for Planet X is shown dotted. Well, we'll have the formula of like lambda equals 2.9 times 10 minus 3 over T. So let's go for Planet X. Planet X has a lower temperature than Y. So a lower denominator means a higher lambda. So lambda x is more than lambda y. As for the intensity, well, higher temperature has a higher intensity just because it has more energy and stuff like that. So uh, x is dotted. So let's at least see the wavelength for this one. Lambda for x is less than lambda for y, so this is wrong. And this one, lambda for x is less than lambda for y, so that's also wrong. So it has to be one of these. And because x has a smaller temperature, that means that the intensity has to be lower. So the answer is D, because the lambda of x is greater than lambda of y, and the intensity of y is more than the intensity of x. The average surface temperature on Mars is approximately 200 Kelvin, and the average surface temperature on Earth is approximately 200 Kelvin. Mars has a radius half that of Earth. Assume that both Mars and Earth act as black bodies. What is power radiated by Mars divided by power radiated by Earth? So we'll get the formula of power equals to emissivity times a t to the power 4. So Mars has a radius half of Earth. So Earth has twice the radius. Twice the radius. So if you check your formula booklet, because it's a sphere, right? The surface, we'll be using the surface area, which is 4 pi r squared. So the area of Earth is going to be 4 pi and then times 4 again r squared, because Mars has twice the radius of Mars. So power of E equals to E 4 pi 4 r squared times 300 to the power 4. And then P of M is E da, 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 4 pi r squared, and then 200 to the power 4. So it's Mars divided by Earth, so these cancel out, this cancels out, that cancels out, that cancels out. So Pm over Pe will become 4 times 300 to the power 4 over 200 to the power of... Wait, no, wrong way. It'll be 200 to the power 4 over 300 to the power 4 times 4. So it'll become... We'll get rid of these hundreds to the power 4 because, yeah, it's just 2 times 100 to the power 4 divided by 3 times 100 to the power 4. And then 2 to the power of 4 divided by 4 is 4. So you'll have 4 over 3 to the power of 4. So that's basically like 4 divided by 9 times 9. And if we round 9 to 10, it'll be basically 4 over 10 times 10 over 100. So you'll have about like 0.04. So the closest one will be D. And that's the answer.